Flow controller in Apache NiFi. Now we are focusing on flow controller. The flow controller is the brains of the operation. It provides threads for extensions to run on and manages the schedule of when extension received resources to execute. The flow controller maintains the knowledge of how processors connect and manages the threads and allocates thereof which all processors use. The flow controller acts as a broker, facilitating the exchange of flow files between processors. Here you can see an AWS credentials service provide context to two processors. The flow controller is the glue that brings everything together. It allocates and manages threads for processors. It's what executes the data flow. Also, the flow controller makes it possible to add controller services. Those services facilitate the management of shared resources like database connections and cloud services provider credentials. Controller services are daemons. They run in the background and provide configuration, resources, and parameters for processors to execute. For example, you may use AWS credentials provider service to make it possible for your services to interact with S3 buckets without having to worry about credentials at the processor level. Just like with processors, a multitude of controller services is available out of box. Here you can see a processor flow file connector and flow file controller for essential concepts in NiFi. To express your data flow in NiFi, you must first master its language. No worries, a few terms are enough to grasp the concept behind it. Black boxes are called processors, and they exchange chunks of information named flow files through queues that are named connections. Connections. Yeah. Finally, the flow file controller is responsible for managing the resources between those components. Here you can see a processor. Processor 1 is connected to processor 1 interacts with processor 2 through a connector. Flow files are inside the connector, and processor, flow file, connector and connector are inside the controller. Here you can see flow file anatomy of a flow file. It contains attributes of data as well as a reference to associated data. In NiFi, the flow file is the information packet moving through the processes of the pipeline. Flow file comes in two parts: attributes, which are key value pairs. For example, file name, file path, and a unique identifier are standard attributes. Content, a reference to the stream of bytes composed of stream of bytes compose the flow file content. Flow file does not contain the data itself. That would severely limit the throughput of the pipeline. Here you can see the flow file, and you can attributes and contents are inside flow file. As an example, we can consider this property in NiFi.properties file. NiFi.h2.url.append. This property specifies additional arguments to add to the connection string for the H2 database. The default value should be used and should not be changed. It is lock underscore timeout equal 25,000 and write underscore delay equal 0 and auto underscore server equal false. As an example 2, we can consider controller service API, a class controller service API. This is in the package org.apache.nifi.flow. As an flow REST API example, we can consider this one in flow. Get /flow /controller service types retrieves the types of controller services that this NiFi supports. Note this endpoint is subject to change as NiFi and its REST API evolve. The request is consumes */ response produces JSON for application /JSON. As an example 4, we can consider H2 settings in system properties. The H2 settings section defines the settings for H2 database, which keep track of user access and flow controller history. Here the property NiFi.database.directory strict the location of the H2 database directory. The default value is /database_repository. Now we are considering adding management controller services. Select the desired controller service and click add, or simply double click the name of the service to add it. To add management controller service, select controller settings from the global menu. This displays the NiFi settings window. This window has 5 tabs: general, management controller services, reporting tasks, registry client, and parameter providers. General tab provides settings for the overall maximum thread counts of the instance. To right of the general tab is the management controller services tab. From this tab, the DFM may click the plus button in the upper right corner to create new controller service. The add controller service window opens. This window is similar to the add processor window. It provides a list of available controller services. On the right hand, and the tag cloud showing the most common category tags used for controller services. On the left, the DFM may click any tag in the tag cloud in order to narrow down the list of controller services to those that fit the category desired. The DFM may also use the filter field at the top right of the window to search for the desired controller service, or use the source drop down at the top left to filter the list by the group who created them. Upon selecting the controller service from the list, the DFM can see the description service below. Select the desired controller service and click add, or simply double click the name of the service to add it. Once you added a controller service, you can configure it by clicking configure button on the far right column. Now we are considering adding controller service for data flows. When you select the process group on the canvas and then click configure from either operate palette or the process group context menu, the service will be available to all processes and controller services defined in that process group here. To add the controller service for a data flow, you can either right click the process group and select configure, or click configure from the operate palette. When you click configure from the operate palette with nothing selected on your canvas, you add a controller service for your root process group. The controller service is then available to all nested process groups in your data flow. When you select process group on the canvas and then click configure from the either operate palette or the process group context menu, the service will be available to all processes and controller services defined in the process group. Use the following steps to add the controller service. Click configure either from the operate palette or from the process group context menu. This displays the process group configuration window. The window has two tabs, General and Controller Services. The General tab is for settings that pertain to general information about process group. From the process group configuration page, select the Controller Services tab. Click plus button to display Add Controller Service dialog. Select controller service desired and then click add. Perform the necessary controller service configuration task by clicking the configure icon. In the right hand column, here you can see the process group context of this configuration dialog. Here click to add controller service, and here description of availability. Here the controller service defined in the current group can be edited. Navigate to the service when it's defined in an ancestor group. Now we are considering enabling and disabling controller service. When enabling a controller service, the DFM has the option to either enable the controller service and all referencing components, or enable only the controller service itself. After a controller service has been configured, it must be enabled in order to run. Do this using enable button in the far right column of the controller service tab. In order to modify existing running controller service, the DFN needs to disable it as well as referencing reporting tasks and controller services. To do this using the disable button, rather than having to hunt down each component that is referenced by the controller service. The DFM has the ability to stop, disable, them when disabling the control service in question. When enabling a control service, DFM has the option to either start to enable the control service and all referencing components, or start to enable only the control service itself. Now we are considering restricted controller service created in root process group in restricted component in version flows in versioning data flow. The key tab credential service controller service is a restricted component that requires access key tab permissions here. Now we are considering a restricted controller service created in a process group. Here the test user changes the flow by removing the key tab credential service controller service. However, with this configuration, if test user attempt to revert this change here, the revert is unsuccessful because test user does not have the access key tab permission required by the key tab credential service controller service. This is an example showing. As an error example, we can consider this error occurred in NiFi under NiFi 1.7.1 release build cluster of 3 nodes. Other nodes for Zookeeper, Java 1.8 build 181. The error is error NiFi logging handler org.apache.nifi.std err failed to start web server, unable to start flow controller. Now we are focusing on processor 1. Processors actually perform the work. In terms, a processor is doing some combination of data routing, transformation, or mediation between systems. Processors have access to attributes of a given flow file and its content stream. Processors can operate on 0 or more flow files in a given unit of work and either commit that work or roll back. Here you can see an example of uploading files from SFTP server to HDFS. NiFi uses a web interface to create a data flow. The analyst who recently started working with Hadoop, the developer, and bearded admin will cope with it. The last two can interact only with rectangles and arrows, but also with REST API for collecting statistics, monitoring, and managing data for components. Here I will show a few data flow one data flow example with some common operations. In this example, the list SFTP processor lists files on a remote server. And the result of this listing is used for parallel downloading of files by all the nodes of the cluster by the fetch SFTP processor. After this, attributes are added to each file obtained by passing its name, which then are used by the put HDFS processor when writing the file to the final directory. Here you can see a list. SFTP is connected with test2. Test2 is connected to NiFi flow, and here input is connected with queued, and queued 0 is connected to fetch SFTP, and fetched FSTP is connected with the permission denied not underscore f4, and it is connected to log attribute, and fetch SFTP is connected with commands.failure, and commands.failure is connected to fetch SFTP, and fetch SFTP is connected with success, and success is connected to update attribute. Update attribute is connected with success, and success is connected to put HDFS. Here you can see anatomy of a processor. NiFi provides a significant amount of information about each processor on the canvas. This diagram shows the anatomy of a processor. This has the number of elements. Processor type. NiFi provides several different types of processors in order to allow for a wide range of tasks to be performed. Each type of processor is designed to perform one specific task. The processor type, put file in this example, describes the task that this processor performs. In this case, the processor writes a flow file to the disk, or puts a flow file to a file. Bulleting indicator. When a processor logs that some event has occurred, it generates a bulletin to notify those who are monitoring NiFi via the user interface. The DFM is able to configure which bulletins should be displayed in the user interface by updating the bulletin level field in the settings tab of the processor configuration dialog. The default value is warn, which means that only warnings and errors will be displayed in the UI. This icon is not present unless a bulletin exists for this processor. When it is present, hovering over the icon with the mouse will provide a tooltip explaining the message provided by the processor as well as the bulletin level. If the instance of NiFi is clustered, it will also show the node that emitted the bulletin. Bulletins automatically expire after 5 minutes. Status indicator. This shows the current status of the processor. The indicators, the possible indicators are running. The processor is currently running, and stopped. The process is valid and enabled, but is not running. Invalid. The processor is enabled but is not currently valid and cannot be started. Hovering over this icon will provide the tooltip indicating why the process is not valid. And disabled. The process is not running and cannot be started until it has been enabled. This status does not indicate whether or not the process is valid. Here you can see running state, running status indicator here. Processor name. This is the user defined name of the processor. By default, the name of the processor is the same as the processor type. In this example, the value is copy to /review. Active tasks. The number of tasks that this processor is currently executing. This number is constrained by the concurrent task settings in the scheduling tab of the processor configuration dialog. Here we can see that the processor is currently performing one task. If the NiFi instance is clustered, this value represents the number of tasks that are currently executing across all the nodes in the cluster. 5-minute statistics. The processor shows several different statistics in a tabular form. Each of these statistics represent the amount of work that has been performed in the past 5 minutes. If NiFi instance is clustered, these values indicate how much work has been done by all the nodes combined in the past 5 minutes. These metrics are in the amount of data that the processor has pulled from the queue of its incoming connections. This value is represented as count and size, where count is the number of flow files that have been pulled from the queue, and size is the total size of those flow files content. In this example, the processor is just pulled 29 flow files from the input queues for total of 14.16 megabytes. Read write. The total of the flow file content that the processor has read from the disk and written to disk. This provides valuable information about the I/O performance that this processor requires. Some processors may only read the data without writing anything, while some will not read the data but will only write data. Others will never read nor write data, and some processors will both read and write data. In this example, we see that in the past 5 minutes the processor has read 4.88 MB of the flow file content and has written 4.88 MB as well. This is what we would expect, since this processor simply copies the content of the flow file to the disk. Note, however, this is not the same as the amount of data that pulled from the input queues. This is because some of the files that it pulls from the input queues already exist in the output directory, and the processor is configured to route flow files to failure when it occurs. Therefore, for those files which already existed in the output directory, data was neither read nor written to disks. Out. The amount of data that processor has transformed to its outbound connections. This does not include flow files that the processor removed itself, or flow files that are routed to connections that are auto-terminated. Like in metric above, this value is represented as count, where count is the number of flow files that have been transferred to outbound connections, and size is the total size of those flow files content. In this example, all of the relationships are configured to be auto terminated, so no flow files are reported as having been transferred out. Tasks time. The number of times that this processor has been triggered to run in the past 5 minutes, and the amount of time taken to perform these tasks. The format of the time is hour, minutes, and seconds. Note that the amount of time taken can exceeded 5 minutes, because many tasks can be executed in parallel. For instance, if a processor is scheduled to run with 60 concurrent tasks, and each of these tasks takes 1 second to complete, it is possible that 60 tasks will be completed in a single second. However, in this case, we will see the time metric showing that it took 60 seconds instead of 1 second. This time can be thought of as system time, or said another way, this value is 60 seconds because that's the amount of time that would have taken to perform action if only a single concurrent task were used. And here you can see a processor. Here you can see a status symbol, processor name, processor type, 5 minute statistics, bulletin indicator, and active tasks. Here you can see processor life cycle. Processor initialization is connected to processor exposing processor relationships, and it is connected to exposing processor properties, and it is connected to validating processor properties, and it is connected to triggered and performing the work, and it is connected to process process session finish. Here you can see a component life cycle. The NiFi API provides lifecycle support through the use of Java annotations. The org.apache.nifi.annotation.lifecycle package contains several annotations for lifecycle management. The following annotations for lifecycle annotation may be applied to Java methods in an NiFi components to indicate to the framework when the methods should be called. For the discussion of component lifecycle, we will define NiFi components as a processor, controller services, parameter providers, or reporting task. At onAdded, the at onAdded annotation causes a method to be invoked as soon as a component is created. The component's initialized method or init method of if subclass abstract processor will be invoked after the component is constructed, followed by the method that annotated with onAdded. If any method annotated with onAdded throws an exception, an error will be returned to the user, and that component will not be added to the flow. Furthermore, other methods with this annotation will not be invoked. This method will be called only once for lifetime of a component. Method with this annotation must take 0 arguments. At enabled, the at onenabled, the at onenabled annotation can be used to indicate the method should be called whenever the control is enabled. Any method that has this annotation will be called every time the user enables the service. Additionally, each time that NiFi is restarted, if NiFi is configured to auto resume state, the service is enabled, the method will be invoked. If a method with this annotation throws a throwable or log message, and bulletin will be issued for the component, in this event, the service will remain in an enabling state and will not be usable. All methods with this annotation will then be called again after a delay. A service will not be made available for use until all methods with this annotation have returned without throwing anything. The method using this annotation must take either 0 arguments or a single argument of the type org.apache.nifi.controller.configuration context. Note that annotation will be ignored if applied to a reporting task, parameter provider, or processor. For a controller service, enabling and disabling are considered lifecycle events as the action make them usable or unusable by other components. However, a processor and a reporting task, these are not lifecycle events but rather a mechanism to allow a component to be excluded when starting or stopping a group of components. At onRemoved, the at onRemoved annotation causes a method to be invoked before a component is removed from the flow. This allows resources to be cleaned up before removing a component. Method with this annotation must take 0 argument. If a method with this annotation throws an exception, the component will still be removed. At onScheduled, this annotation indicates that the method should be called every time the component is scheduled to run. Because controller services are not scheduled, using this annotation on a controller service does not make sense and will not be honored. It should be used only for processors and reporting tasks. If any method with this annotation throws an exception, other methods with this annotation will not be invoked, and a notification will be presented to the user. In this case, methods annotated with at onScheduled are then triggered, followed by method with the at onStop annotation during this state. If any of these methods throws an exception, those exceptions are ignored. The component will then yield this execution for some period of time, referred to as the administrative yield duration, which is a value that is configured in the NiFi.properties file. Finally, the process will start again until all the methods annotated with at onSchedule have returned without throwing any exception. Method with this annotation may take 0 arguments or take a single argument. If if a single argument variation is used, the argument must be a type of process context. If the component is a processor, or configuration context if the component is a reporting task. On unscheduled, method with this annotation will be called whenever a processor or reporting task is no longer scheduled to run. At that time, many threads may still be activated in the processor's onTrigger method. If such a method throws an exception, the log message will be generated, and then exception will be otherwise ignored, and other method will with this annotation will still be invoked. Method with this annotation and maybe may take 0 arguments, or may take a single argument. If the single argument variation is used, the argument must be of type process context if the component is a processor, or configuration context if the component is a reporting task. At onStopped, method with this annotation will be called when a processor or reporting task is no longer scheduled to run, and all threads have returned from the onTrigger method. If such a method throws an exception, a log message will be generated, and the exception will otherwise be ignored. Other methods with this annotation will still be invoked. Methods with this annotation are permitted to take either 0 or 1 argument. If an argument is used, it must be of type configuration context if the component is a reporting task, or of type process context if the component is a processor. At onShutdown, any method with this annotated with the at onShutdown annotation will be called when NiFi is successfully shut down. If such a method throws an exception, a log message will be generated, and the exception will be otherwise ignored, and other method with this annotation will still be invoked. Method with this annotation must take 0 arguments. Note: while Wi-Fi will attempt to invoke methods with this annotation on components that use it, this is not always possible. For example, the process may be killed unexpectedly, in which case does not have a chance to invoke these methods. Therefore, while methods using this annotation can be used to clean up resources, for instance, they should not be relied upon critical business logic. With the API, the annotation type on added, the mark annotation of a processor, control service, or reporting task implementation can use to indicate a method should be called whenever the component is added to the flow. This method will be called once for entire life of a component instant. The annotation type on configuration restored, mark annotation that the processor, reporting task, or a control service can use to indicate that method with this annotation should be invoked whether component's configuration is restored after a restart of NiFi. Annotation type on disabled, mark annotation of a control service can use to indicate a method should be called whenever the service is disabled. Annotation type on enabled, mark annotation of a control service that can use to indicate method should be called whenever the service is enabled. Any method that has the annotation will be called every time a user enables the service. Additionally, each time the NiFi is restarted, if NiFi is configured to auto resume state and the service is enabled, the method will be invoked. Annotation type on removed, mark annotation of a processor, control service, or reporting task implementation can use to indicate a method should be called whenever the component is removed from the flow. This method will be called once for entire life of a component instance. If the method throw any throwable, that throwable will be caught and logged, but will not prevent subsequent methods with this annotation or removal of the component flow from the flow. Annotation type on scheduled, mark annotation of a processor or reporting task implementation can use to indicate a method should be called whenever the component is scheduled to run. This will be called before any call to onTrigger and will be called once each time a processor or reporting task is scheduled to run. This occurs in one of two ways. Either a user click on a schedule, user click to the scheduled the component to run, or NiFi is restarted with auto resume state configuration set to true, the default value, and the component is already running. Annotation type on shutdown. Mark annotation of a processor, controller, or reporting task implementation can use to indicate a method should be called whenever the flow is being shut down. This will be called at most once for each component in a JVM lifecycle. It is not, however, guaranteed that this method will be called on shutdown, as the service may be killed suddenly. Annotation type on stopped. The mark annotation of a processor or reporting task implementation can use to indicate that the method should be called wherever the component is no longer on the schedule to run. Methods marked with this annotation will be invoked each time the component is stopped, and will be invoked only after the last thread has returned from the onTrigger method. Annotation type on unscheduled. Mark annotation of a processor or reporting task should be called whenever a component is no longer scheduled to run. Methods marked with this annotation will be invoked each time the framework is notified to stop scheduling component. This method is invoked as other threads are potentially running. To invoke a method after all threads have finished processing. See the unstopped annotation. See the on stopped annotation. Here you can see at on added is connected to at on enabled, and at on enable is connected to at on removed, and at on removed is connected to at on scheduled, and it is connected to at on unscheduled, and it's connected to at on stopped, and it is connected to at on shutdown. We can consider this as an example here. Validating processor properties. A processor is not able to be started if its configuration is not valid. Validation of a processor property can be achieved by setting validator on the property descriptor, or by restriction allowable values for the property via the property descriptor dot builders allowable values method, or identifies control service method. In addition, if a property is dependent on another property by means of the property descriptor dot builders depends on method, and the dependency is not satisfied, then the property will be validated. For example, we can consider these two property descriptors. In this case, if the use file property is set to true, then the processor will not be valid unless file to use property is set to a valid file name. If the use file is set to true and file to use does not have a value set, the processor will be invalid because file to use property is required. If use file is set to true, and the file to use has a value set by the value set, but the specified file does not exist, the processor will also be invalid because the file to use property is invalid according to the validator. However, if the use file property is set to false, then the file to use property is said to have a dependency that is not satisfied. As a result, the file to use property will not be considered in the validation. Therefore, if the use file is set to false and file to use has no values set, the processor will still be valid even though file to use is required. It is only required if the file use file is true. Likewise, if file to use is set to non-existent file name such as /file /that /does /not /exist, the processor will still be valid as long as use file property is set to false. Furthermore, the file to use property will not be shown in the NiFi UI unless use file is set to false. There are times though when validating a processor properties individually is not sufficient. For this purpose, an abstract processor exposes a custom validate method. As an example too, we can consider this code segment. Here you can see this trick class is extending abstract processor and it's overriding on trigger method here. As an error example, we can consider this one, this exception. As an exception example, we can consider this one, process exception. Indicates an issue occurred in user code while processing a flow file. In this tab contains several different configuration items. First, it allows the DFM to change the name of the processor. The name of a processor by default is the name is the same as the processor type. Next to the processor name is a checkbox indicating whether the processor is enabled. When a processor is added to the canvas, it is enabled. If the processor is disabled, it cannot be started. The disabled state is used to indicate that when a group of processors are started, when such as when DFM starts an entire process group, this disabled processor should be excluded. Below the name configuration, the processor's unique identifier is displayed along with the processor's type. And NAR bundle. These values cannot be modified. Next are two dialogues for configuring penalty duration and yield duration. During the normal course of processing a piece of data, a flow file, an event may occur that indicates that the data cannot be processed at this time, but the data may be processable at a later time. When this occurs, the processor may choose to penalize the flow file. This will prevent the flow file from being processed for some period of time. For example, if the processor is to push the data to a remote service, but the remote service already has a file with the same name as a file name that processor is specifying, the processor may penalize the flow file. Penalty duration allows the DFM to specify how long the flow file should be penalized. The default value is 30 seconds. Similarly, the processor may determine that some situation exists such that the processor can no longer make any progress, regardless of the data that is processing. For example, if a processor is to push data to a remote service and that service is not responding, the processor cannot make any progress. As a result, processor should yield, which will prevent the processor from being scheduled to run some period of time. That period of time is specified by setting the yield duration. The default value is 1 second. The last configuration option on the left hand side of settings tab is the bulleting level. Whenever the processor writes to its log, the processor will generate a bulletin. These settings indicate the lowest level of bulletin that should be shown in the user interface. By default, the bulletin level is set to 1, which means that it will display all warning and error level bulletins. The right hand side of the settings tab contain an automatically terminate relationships section. Each of the relationships that is defined by the processor is listed here along with its description. In order for a processor to be considered valid and able to run, each relationship defined by the processor must be either connected to a downstream component or auto-terminated. If a relationship is auto-terminated, any flow file that is routed to the relationship will be removed from the flow and its processing considered complete. Any relationship that is already connected to downstream component cannot be auto-terminated. The relationship must first be removed from any connection that uses it. Additionally, for any relationship that is selected to be auto-terminated, the auto-termination status will be cleared, turned off if the relationship is added to the connection. And you can also see scheduling tab. And properties and commands. So in summary, as an example we can consider package org.apache.nifi.processor. So we can consider interface processor. Processor objects operates on flow file objects where the processors are linked together via relationships forming a directed graph structure. This is the package org.apache.nifi.processor. We can consider processors in REST API, post /processors /run status details /queries. Submit a query to retrieve the run status details of all processors that are in the given list of processor IDs. The request consumes application /JSON and response produces application /JSON. Now we are considering adding a processor. This will give us a dialog that allows us to choose which processor we want to add. We can now begin creating our data flow by adding a processor to our canvas. To do this, drag the processor icon from the top left of the screen to into the middle of the canvas, the graph paper like background, and drop it there. This will give us a dialog that allows us to choose which processor we want to add. We have quite a few options to choose from. For sake of becoming oriented with the system, let's say that we just want to bring in files from our local disk into NiFi. When the developer creates a processor, that developer can assign tags to that processor. This can be thought of as keywords. We can filter by these tags or by processor name by typing into filter box in the top right corner of the dialog. Type the keywords that you would think of when wanting to ingest files from a local disk. Typing the keyword file, for instance, will provide us a few different processors that deal with files. Filtering by the term local will narrow down the list pretty quickly as well. If we select a processor from the list, we will see the brief description of the processor nearer the bottom of the dialog. This should tell us exactly what processor does. The description of get file tells us that it pulls data from our local disk into NiFi and then removes the local file. We can double click on the processor, type or select it, and then choose the add button. The processor will be added to the canvas in the location that it was dropped. Now we are considering configuring a processor. If we set the directory name to ./data-in, this will cause the processor to start picking up any data in the data in subdirectory of the NiFi home directory. Now that we have added the get file processor, for example, we can configure it by right clicking the processor and choosing the configure menu item. We are considering a different example where we added the get file processor. The provided dialog allows us to configure many different options that can be read about the user guide. But for sake of this guide, we will focus on the properties tab. Once the properties tab has been selected, we are giving a list of several different properties that we can configure the processor. Properties that are available depend on the type of the processor, that are generally different for each type. Properties that are in bold are required properties. The processor cannot be started until all required properties have been configured. The most important property to configure for get file, for example, is the directory from which to pick up files. If we set the directory name to ./data-in, we will get this will cause the processor to start picking up any data in the data-in subdirectory of the NiFi home directory. We can choose to configure several different properties for this processor. If unsure what a particular property does, we can hover over the help icon next to the property name with the mouse in order to read the description of the property. Additionally, the tooltip that is displayed when hovering over the help icon will provide the default value for that property. If one exists, the information about whether or not the property supports the expression language and previously configured values for this property. In order for this property to be valid, create a directory name data-in in NiFi home directory, and then click OK button to close the dialog. Now we are considering connecting processors. Clicking on the settings tab provides a handful of options for configuring how this connection should behave. Each processor has a set of defined relationship that it is able to send data to. When a processor finishes handling a flow file, it transfers it to one of these relationships. This allows a user to configure how to handle flow files based on the result of processing. For example, many processors define two relationships, success and failure. Users are then able to configure data to be routed through the flow one way, or if the processor is able to successfully process the data and route the data through the flow in a completely different manner if the processor cannot process the data for some reason, or depending on the use case, it may simply route both relationships to the same route through the flow. Now that we have added and configured our get file processor, applied the configuration, we can see in the top left corner of the processor alert icon signaling that the processor is not in a valid state. Hovering over this icon, we can see the success relationship has been defined. This simply means that we have not told NiFi what to do with the data that processor transferred to the success relationships. In order to address this, let's add another processor that we can connect the get file processor, for example, to by following same steps above. This time, however, we will simply log the attributes that exist for the flow file. To do this, we will add the log attribute processor. We can now send the output to the get file processor to the log attribute processor. Hover over the get file processor with the mouse, and connection icon will appear in the middle of the processor. We can drag the icon from the get file processor to log attribute processor. This gives us the dialog dialog to choose which relationships we want to include for this connection. Because get file has only a single relationship success, it is automatically selected for us. Clicking on the settings tab provides a handful of options for configuring how this connection should behave. We can give a connection name if we like. Otherwise, the connection name will be based on the selected relationships. We can also set an expiration for the data. By default, it is set to 0 second, which indicates that the data should not expire. However, we can change the value so that when data in this connection reaches a certain age, it will automatically be deleted, and a corresponding expire provenance event will be created. The back pressure threshold allows us to specify how full the queue is allowed to become before the source processor is no longer scheduled to run. This allows us to handle cases where one processor is capable of producing data faster than the next processor is capable of consuming the data. The back pressure is configured for each connection along the way. The processor that is bringing data into the system will eventually experience the back pressure and stop bringing new data, so that our system has ability to recover. Finally, we have prioritizers on the right hand side. This allows us to control how the data in this queue is ordered. We can drag the prioritizers from the available prioritizers list to the selected prioritizers. list in the order to activate the prioritizer. If multiple prioritizers are activated, they will be evaluated such as the prioritizer list first will be evaluated first, and if two flow files are determined to be equal according to that prioritizer, the second prioritizer will be used. For the sake of this discussion, we simply click add the connection to our graph. We should now see that the alert icon has changed to stopped icon. The log attribute processor, however, is now invalid because its success relationship has not been connected to anything. Let's address this by signaling that data that is routed to success by log attribute should be auto terminated, meaning that NiFi should consider the flow file processing complete and drop the data. To do this, we configure the log attribute processor. On the settings tab, the right hand side, we can check the box next to success relationship to auto terminate the data. Clicking OK will close dialog and show that both processes are now stopped. Now we are considering start and stopping processes. In order to start the processes, we can click on each one individually and then right click and choose start menu item. At this point, we have two processes on our graph, but nothing is happening. In order to start the processes, we can click on each one individually and then right click and then choose start menu item. Alternatively, we can select the first processor, then hold the shift while selecting this other processor in order to select both. Then we can right click and choose start menu item as an alternative to using the context menu. We can select processors and then click the start menu start icon in the operate palette. Once started, the icon on the top left corner of the processors will change from a stop icon to a running icon. We can then stop the processes by clicking stop icon in the operate palette or the stop menu item. Once the processes has started, we are not able to configure it anymore. Instead, we can we right click the processor. We are given the option to view its current configuration. In order to configure a processor, we must first stop the processor and wait for any task that may be executing to finish. The number of tasks currently executing is shown near the top right corner of the processor, but nothing is shown where if there is currently no tasks. Getting more info for a processor. To address this, you are able to right click on the processor and choose usage menu item. With this with each processor having the ability to expose the multiple different properties and relationships, it can be challenging to remember how all of the different pieces work for each processor. To address this, you are able to right click on a processor and choose the usage menu item. This will produce you with the processor's usage information, such as description of the processor, different relationships that are available, and when the different relationships are used, properties that are exposed by the processor and their documentation, as well as which flow file attributes, if any, are expected on incoming flow files, and which attributes, if any, are added to outgoing flow files. And we can consider other components. These components include input and output ports, funnels, process groups, and remote process groups. The toolbar that provides users the ability to drag and drop processes into graph includes several other components that can be used to build a data flow. These components include input and output ports, funnels, process groups, and remote process groups. Due to the intended scope of this presentation, we will not discuss each these element here much. Now we are considering settings tab. The first tab in the processor configuration dialog is the settings tab. This tab contains several different configuration items. First, it allows the DFM to change the name of the processor. The name of the processor by default is the name of the name is the same as the processor type. Next to the processor name is a checkbox indicating whether the processor is enabled. When a processor is added to the canvas, it is enabled. If the processor is disabled, it cannot be started. The disabled state is used to indicate that when a group of processors is started, such as when a DFM is start and entire process group, this disabled processor should be excluded. Below the name configuration, the processor's unique identifier is displayed along with the processor's type, and the NAR bundle. These values cannot be modified. The next two dialogues are configuring penalty duration and yield duration. During normal course of processing a piece of data, a flow file, an event may occur that indicate that the data cannot be processed at this point, but the data may be processable at a later point. When this occurs, the processor may choose to penalize the flow file. This will prevent flow file from being processed for some period of time. For example, a processor is to push the data to remote service, but the remote service already has a file that the same name as the file name that the processor is specifying. The processor may penalize the flow file. The penalty duration allows the DFM to specify how long the flow file should be penalized. The default value is 30 seconds. Similarly, the processor may determine some situations such as the processor may no longer make any progress regardless of their data that is being processing. For example, if a processor is to push data to a remote service and that service is not responding, the processor cannot make any progress. As a result, the processor should yield, which will prevent the processor from being scheduled to run from some period of time. That period of time is specified by setting yield duration. The default value is 1 second. The last configurable option on the left hand side of a settings tab is bulleting level. Whenever the processor writes to its log, the processor also will generate a bulletin. These settings indicate the lowest level of bulletin that should be shown in the user interface. By default, the bulletin level is set to 1, which means that it will display all warning and error level bulletins. Now we are considering scheduling tab. The second tab in the processor configuration dialog is the scheduling tab. The first configuration option is the scheduling strategy. There are 3 possible options for scheduling components. Timer driven. This is the default mode. The processor will be scheduled to run on a regular interval. The interval at which processor is run is defined by run schedule option. Event driven. This mode is when this mode is selected, processor will be triggered to run by an event, and that event occurs when the flow files enter connections feeding this processor. This mode is currently considered experimental and is not supported by all processors. When this mode is selected, the run schedule option is not configurable, as the processor will not trigger to run periodically but as the result of an event. Additionally, this is the only mode for which the concurrent tasks option can be set to 0. In this case, the number of threads is limited only by the size of the event-driven thread pool that the administrator has configured. Experimental. This implementation is marked experimental as of Apache NiFi 1.10.0 October 2019. The API configuration and internal behavior may change without warning, and such changes may occur during the minor release. Use at your own risk. Cron-driven. When using cron-driven scheduling mode, the processor is scheduled to run periodically, similar to the timer-driven scheduling mode. However, the cron-driven mode provides significantly more flexibility at the expense increasing complexity and of the configuration. Cron-driven scheduling value is a string of 6 required fields on and 1 optional field, each separated by space. These fields are seconds, minutes, hours, day of month, day of week, year, optional. You typically specify values on the following ways. Number, you specify one or more valid value. You can enter more than one value using a comma separated list. Range, specify a range using number syntax. Increment, specify an increment using start value / increment syntax. For example, in the minutes field, 0 divided by 15 indicates the minutes of 0, 15, 30 and 45. You should also be aware of several valid special characters. Asterisks indicate that all values are valid for that field. Question mark indicates that no specific value is specified. This special character is valid in the days of month and days of the week. L, you can append L to one of the day of week values to specify last occurrence of this day in the month. For example, 1L indicates the last Sunday of the month. Concurrent tasks. Next, the scheduling tab provides the configuration option named configure concurrent task. This controls how many threads that the processor will use. Set a different way. This controls how many flow files should be processed by this processor at the same time. Increasing this value will typically allow a processor to handle more data in the same amount of time. However, it does this by using system resources that then are not usable by other processors. This essentially provides more relative weighting of the processors. It controls how much of the system's resource should be allocated to this processor instead of other processors. This field is available for most processors these are however some types of processors that can only be scheduled with single concurrent tasks. Run schedule. The run schedule dictates how often the process should be scheduled to run. The valid values for this field depending on selected scheduling strategy. If using the event-driven scheduling strategy, this field is not available. When using the timer-driven scheduling strategy, this value is a time duration specified by a number followed by the time unit. For example, 1 second or 5 minutes. The default value of 0 seconds means that the processor should run as often as possible as long as it has data to process. This is true for any time duration of 0 regardless of a time unit. For example, 0 sec, 1 means 0 days. For an explanation of values that are applicable for cron-driven scheduling strategies, you can check a description of a cron-driven scheduling strategy in the documentation. Execution. The execution setting is used to determine on which nodes the processor will be scheduled to execute. All nodes will result in this processor being scheduled on every node in the cluster. Selecting primary node will result in this processor being scheduled on the primary node only. Processes that have been configured for primary node execution are identified by a P next to the processor icon. To quickly identify primary node processors, the P icon is also shown in the processors tab. On the summary page. Run duration. The right hand side of the scheduling tab contains a slider for choosing run duration. This controls how long the processor should be scheduled to run each time that is triggered. On the left hand side of the slider, it is marked lower tenancy, while the right hand side is marked higher throughput. When the processor finishes running, it must update the repository in order to transfer the flow file to the next connection. Updating the repository is expensive, so the more work that can be done at once before updating the repository, the more work the processor can handle, higher throughput. However, this means that the next processor cannot start processing those flow files until the previous process updates this repository. As a result, the latency will be longer. The time required to process the flow file from beginning to end will be longer. As a result, the slider provides a spectrum from which the DFM can choose to favor lower latency or higher throughput. Now we are considering properties tab. Here we see the properties tab for a root on attribute processor. The properties tab provides a mechanism to configure processor specific behavior. There are no default properties. Each type of processor must define which properties make sense for its use case. Here we can see the properties tab for root on attribute processor. This processor by default has only single property, routing strategy. The default value is the root to property name. Next to the name of this property, a small question mark symbol. This help symbol is seen in other places throughout the user interface, and it indicates that more information is available. Hovering over this symbol with the mouse will provide additional details about the property and the default value as well as historical values that has been set for the property. Clicking on the value for the property will allow DFM to change the value depending on the values that are allowed for the property. the user is either provided a drop down from which to choose a value for its value, or is given a text area to type a value. In the top right corner of the tab is a button for adding new property. Clicking this button will provide a DFM with a dialog to enter the name and the value of a new property. Not all processes allow user-defined properties. In processes that are not that do not allow them, the processor becomes invalid, and when user-defined properties are applied. Selected processes support configurable sensitive values status for user-defined properties. Properties must indicate support for configurable sensitive value status, otherwise the sensitive value section will be disabled in the property dialog. Selecting yes for sensitive value settings instructs NiFi to handle the property value as a sensitive for configuration, persistence, and framework operations. NiFi encrypts sensitive values when storing the flow configuration and does not include sensitive values in exported flow files. Root on attribute allows user-defined properties and will not be valid until the user has added the property. Note that after a user-defined property has been added, the icon will appear on the right hand side of that row. Clicking it will remove the user-defined property from the processor. Some processors also have an advanced user interface UI built into them. For example, update attribute processor has an advanced UI. To access the advanced UI, click the advanced button that appeared at the bottom of the configure processor window. Only processors that have advanced UI have this button. Some processors have properties that refer to other components such as controller services, which also need to be configured. For example, get HTTP processor has an SSL context service property which refers to the standard SSL context service controller service. When DFMs want to configure this property but have not yet created and configured the controller service, they have the option to create the service on the spot as depicted on the spot. Now we are considering relationships tab. Each of the relationships that is defined by the processor is listed here along with its description. Automatically terminated. In order for a processor to be considered valid and able to run, each relationship defined by the processor must be either connected to a downstream component or auto-terminated. If a relationship is auto-terminated, any flow file that is routed through that relationship will be removed from the flow and its processing considered complete. Any relationship that is already connected to the downstream component cannot be auto-terminated. The relationships must first removed from the from any connection that uses it. Additionally, for any relationship that is selected to be auto-terminated, the auto-termination status will be cleared, turned off if the relationships is added to the connection. Automatically retry. Users can also configure whether or not flow files routed to a given relationship should be retried. Number of retry attempts. For relationships set to retry, this number indicates how many times a flow file will attempt to reprocess before it is routed elsewhere. Number of retry back off policy. when a flow file is to be retried, the user can configure the backoff policy with two options. Penalize retry attempts will occur in time, but processor will continue to process other flow files. Yield, no other flow files no other flow file processing will occur until all retry attempts have been made. Retry maximum backoff period. Initial retries are based on the penalty yield or yield duration time is specified in the settings tab. The duration time is repeatedly doubled for every subsequent retry attempts. This number indicates the maximum available time period before another retry attempts occur. If both terminates and retry are selected, any retry logic will happen first, then auto termination. Now we are considering comments tab. Use of the comments tab is optional. The last tab in the processor configuration dialog is the comments tab. This tab simply provides an area for users to include whether comments are appropriate for this component. The use of comments tab is optional. Now we are considering additional help. You can access additional documentation about each processor's usage by right-clicking the processor and selecting usage from the context menu. Alternatively, select help from the global menu in the top right corner of the UI to display the help page with all documentation, including usage documentation for all processes that are available. Click on the desired processor to view usage documentation. Now we are considering processor validation. If the processor is invalid, then the indicator will show a yellow warning indicator with an exclamation mark indicating that there is a problem. Before trying to start a processor, it is important to make sure that the processor configuration is valid. The status indicator is shown in the top left corner of the processor. If the processor is invalid, the indicator will show a yellow warning indicator with an exclamation mark indicating there's a problem. In this case, hovering over the indicator, with the mouse will provide the tooltip showing all of the validation errors for the processor. Once all of the validation errors have been addressed, the status indicator will change to stop icon, indicating that the processor is valid and ready to be started, but currently is not running. Now we are considering Apache NiFi expression language. Subjectlet function get state value. Update attributes processor has stored the key count with the value 20 in state. Here get state value count returns 20. Subjectless function get state value access the processor state values by passing in a string key and getting the value back as a string. This is a special expression. This is a special expression language function that only works with processors that explicitly allow EL to query state. Currently only update attributes does. Now we are considering preserve custom processors in upgrading NiFi. If you have any add a new line to the NiFi properties file to specify this new lib directory. If you have any custom NAS, preserve them during upgrade by storing them in a centralized location as follows. Step 1. Create a second library directory called custom_lib. Move your custom NAS to this new lib directory. That is step 2. Step 3. Add a new line to the NiFi properties file to specify this new lib directory. Now here we are considering available configuration options in processor locations. It is not recommended to use this for custom processors, as this could be lost during a NiFi upgrade. For example, this one, the NiFi.na.library.directory is used for the default location for provided NiFi processors. It is not recommended to use this for custom processors, as those could be lost during a NiFi upgrade. For example, this one. Here we can consider options in encrypt config tool. The password or key to use to encrypt the sensitive processor properties in flow.xml.gz. To show the help here, you can see this one with encrypt config tool -h. Here we can consider processor attribute rolling window. Track a rolling window based on evaluating expression language expression on each flow file and add that value to the processor state. Each flow file will be emitted with the count of flow files and total aggregate value of values processed in the current time window. Now we are considering processor API here. While the processor is an interface that can be implemented directly, it will be extremely rare to do so. So as the org.apache.nifi.processor.abstract processor is the base class for almost all processor implementations. The class abstract processor, this is in package org.apache.nifi.processor. The processor is the most widely used component available in NiFi. Processors are only component to which the access is given to create, remove, modify or inspect flow files, data and attributes. All processors are loaded and instantiated using Java's service loader mechanism. This means that all processors must adhere to the following rules. The processor must have a default constructor. The processor's jar file must contain an entry in the meta info inf/services directory named org.apache.nifi.processor.processor. This is a text file where each line contains the fully qualified class name of a processor. While the processor is an interface that can be implemented directly, it will be extremely rare to do so, as the org.apache.nifi.processor.abstract processor is the base class for almost all processor implementations. The abstract processor class provides a significant amount of functionality, which makes the task of developing a processor much easier and more convenient. For the scope of this document, the scope of this presentation, we will focus primarily on the abstract processor class when dealing with the processor API. Concurrency note: NiFi is highly concurrent framework. This means that all extensions must be thread safe. If unfamiliar with writing concurrent software in Java, it is highly recommended that you familiarize yourself with the principles of Java concurrency. Now we are focusing on flow file in supporting API. A flow file is a logical notion that correlates a piece of data with a set of attributes about that data. Such attributes include the flow file's unique identifier as well as its name, size, and any number of other flow-specific values. While the contents and attributes of a flow file can change, the flow file object is immutable. Modification to the flow file are made possible by process session. Here the interface flow file. A flow file is a logical notion of an item in a flow with its associated attributes and identifier which can be used as a reference to its actual contents. This is in the org.apache.nifi.flow file. The core attributes of a flow files are defined in the org.apache.nifi.flow file.attributes.core attributes enum. The most common attributes you will see are file name, path, and UUID. The string in parentheses is the value of the attributes within core attributes enum and how it appears in the UI API. File name. The file name of the flow file. File name should not contain any directory structure. UUID. A universally unique identifier is assigned to this flow file that distinguishes the flow file from other flow files in the system. Path. Flow file's path indicates the relative directory to which flow file belongs and does not contain the file name. Absolute path. Flow file's absolute path indicates the absolute directory to which a flow file belongs and does not contain the file name. Priority. A numeric value indicating flow file priority. MIME type. MIME.type. The MIME type of the flow file in this flow file. Discard reason. Discard.reason. Specify the reason that flow file being discarded. Alternative identifier. Alternate.identifier indicates an identifier other than the flow file's UUID that is known to refer this flow file. Now we are considering validating processor properties in abstract processor API. For example, consider the following two property descriptors. The class property descriptor, an immutable object for holding information about a type of components property. This is in the package org.apache.nifi.components. A processor is not able to be started if its configuration is not valid. Validation of a processor property can be achieved by setting a validator. On a property descriptor, or by restricting the allowable values for a property via property descriptor builder's allowable values method, or identifies controller service method. In addition, if a property is dependent on another property by means the properties descriptors builders depends on method, and the dependency is not satisfied, then the property will be validated. For example, consider the following two property descriptors. In this case, if the use property here in this case, if the use file property is set to true, then the processor will not be valid unless the file to use property is set to a valid file name. If use file is set to true and the file to use does not have a value set, the processor will be invalid because the file to use property is required. If the use file is set to true and the file to use has a value set but the specified file does not exist, the processor will also be invalid because the file to use property is invalid according to the validator. However, if the use file property is set to false, then the file to use property is said to have a dependency that is not satisfied. As a result, file to use property will not be considered in the validation. Therefore, if use file is set to false and file to use has no value set, the processor will still be valid even though file to use is required. It is only required if use file is true. Likewise, if file to use is set to an non-existent file name such as /file /that /does /not /exist, the processor will still be valid so long as the use file property is set to false. Furthermore, the file to use property will not even be shown in the NiFi UI unless use file is set to true. There are times though when validating a processor's properties individually is not sufficient. For this purpose, the abstract processor exposes a custom validate method. This method takes a single argument of type validation context. The return value of this method is a collection of validation result object that describe any problems that were found during validation. Only those validation result object whose isValid method returns false should be returned. This method will be invoked only if all properties are valid according to the associated validators and allowable values. That is, this method will be called only if all properties are valid in and of themselves, and this method allows for validation of a processor's configuration as a whole. Now we are considering @onAdded in component lifecycle. The at unadded annotation causes a method to be invoked as soon as a component is created. This component's initialize method or init method, if subclass abstract processor, will be invoked after the component is constructed, followed by the method that are annotated with unadded. If any method annotated with at unadded throws an exception, an error will be returned to the user, and that component will not be added to the flow. Furthermore, other methods in this annotation will not be invoked. This method will be called only once for the lifetime of a component. Method in this annotation must take 0 arguments. The API, the annotation type unadded, mark annotation, a processor, controller service, flow registry client, parameter provider, or reporting task implementation can use to indicate a method should be called whenever the component is added to the flow. This method will be called once for the entire life of a component instant. org.apache.nifi.annotation lifecycle is the package this annotation type is in. Now we are considering act on primary node state change in component notification. The at on primary node state change annotation causes a method to be invoked as soon as the state of the primary node in a cluster has changed. Methods with this annotation should take either no arguments or one argument of type primary node state. The primary node state provides context about what changed so that the component can take appropriate action. The primary node state enumerator has two possible values. Elected primary node. The node receiving the state has been elected the primary node of the NiFi cluster, or primary node revoked. The node receiving the state was the primary node but has now had its primary node role revoked. The annotation type on primary node state change, mark annotation that a component can use to indicate that a method should be called whenever the state of the primary node in a cluster has changed. This is in the package org.apache.nifi.annotation.notification. Now we are considering restricted. A restricted component is one that can be used to execute arbitrary unsanitized code provided by the operator through the NiFi REST API or UI, or can be used to obtain or alter the data on the NiFi host system using NiFi OS credentials. A restricted component is one that can be used to execute arbitrary unsanitized code provided by the operator through the NiFi REST API or UI can be used to obtain or alter data NiFi host system using OS credentials. These components could be used by an otherwise authorized NiFi user to go beyond the intended use of the application, escalate privilege, or could expose data about the internals of the NiFi process or the host system. All of these capabilities should be considered privileged, and admins should be aware of these capabilities and explicitly enable them for a subset of trusted users. A processor controller service or reporting task can be marked with the at restricted annotation. This will result the component being treated as restricted and will require a user to be explicitly added to the list of users who can access restricted components. Once a user is permitted to access restricted components, they will be allowed to create and modify this component, assuming all other permissions are permitted without access to restricted components. A user will still be aware this type of component exists, but will be unable to create or modify them even with otherwise sufficient permissions. We can also consider at restricted annotation with this example. Now we are considering state manager. From the processor context, reporting context, and controller service initialization context, components are able to call the getStateManager method, the interface state-manager. The state-manager is responsible for providing NiFi components to a mechanism for storing and retrieving state. This is in the package apache.nifi.components.state. This state manager is responsible for providing a simple API for storing and retrieving state. This mechanism is intended to provide developers with the ability to very easily store a set of key value pairs, retrieve those values, and update them automatically. The state can be stored local to the node or across all nodes in a cluster. It is important to note, however, that this mechanism is intended only to provide a mechanism for storing very simple state. As such, the API simply allows a map string to be stored and retrieved, and for the entire map to be automatically replaced. Moreover, the only implementation that is currently supported for storing cluster-wide state is backed by Zookeeper. As such, the entire state map must be less than 1 MB in size after being serialized. Attempting to store more than this will result in exception being thrown if the interaction required by the processor for managing state are more complex than this. For example, a large amount of data must be stored and retrieved, or individual keys must be stored and fetched individually. Then a different mechanism should be used, for example, communicating with an external database. Now we are considering reporting processor activity. Processor should log event via the component log, which is accessible via the initialization context or by calling the getLogger method of abstract processor. The method method protected final component log getLogger. This is in the class abstract processor, which is in the package org.apache.nifi.processor. Processors are responsible for reporting their activity so that users are able to understand what happens to their data. Processor should log events via the component log, which is accessible via the initialization context or by calling getLogger method of the abstract processor. Additionally, processor should use a provenance reporter interface obtained via the process sessions get provenance reporter method. Now we are considering data ingress in common processor patterns. Processors should follow these patterns include get file, get SFTP, get listen HTTP, and get HTTP. The class get file, this is in the package org.apache.nifi.processors.standard. A processor that ingests data into NiFi has a single relationship named success. This processor generates a new flow file via the process session create method and does not pull flow files from incoming connections. The processor name starts with get or listen, depending on whether it polls an external source or exposes some interface to which external sources can connect. The name ends with the protocol used for communications. Processes that follow this pattern include get file, get SFTP, listen HTTP, and get HTTP. Now we are considering data egress in common processor patterns. Processes that follow this pattern include put email, put SFTP, and post HTTP. Note that the name does not begin with put because this would lead to confusion, since put and post have special meanings when dealing with HTTP. The class put email, this is in the package org.apache.nifi.processors.standard. A processor that publishes data to an external source has two relationships, success and failure. The processor name starts with put followed by the protocol that is used for data transmission. Processors that follow this pattern include put email, put SFTP, and post HTTP. Note that the names does not begin with put because this would lead to confusion, since put and post have special meanings when dealing with HTTP. Now we are considering route-based content one-to-one in common processor patterns. If the property that is specified routing criteria requires processing, such as compiling a regular expression, this processing is done in a method annotated with at scheduled if possible. Annotation type at on scheduled. Mark annotation, a processor or reporting task implementation can use to indicate the method should be called whenever the component is scheduled to run. This will be called before any call to on trigger and will be called once each time a processor or reporting task is scheduled to run. This occurs in one of two ways: either a user clicks to schedule the component to run, or NiFi is restarted with the auto resume state configuration set to true, the default value, and the component is ready to running. This is in the package org.apache.nifi.annotation.lifecycle. A processor that routes data based on its content will take one or two forms: route an incoming flow file to exactly one destination, or route incoming data to 0 or more destination. Here we will discuss the first case. The processor has two relationships, matched and unmatched. If a particular data format is expected, the processor will also have a failure relationship that is used when the input is not expected to the format. The processor exposes the property that indicate routing criteria. If the property that is specified the routing criteria required processing, such as compiling a regular expression, this processing is done in a method annotated with at on scheduled if possible. The result is then stored in a member variable that is marked as volatile. Now we are considering route based on content one-to-many in common processor patterns. In order for the user to be able to define additional properties, the get support dynamic property descriptor method must be overridden. Method protected property descriptor get supported dynamic property descriptor string property descriptor name used to allow subclasses to determine what property descriptor, if any, to use when a property is requested for which a descriptor is not already registered. By default, this method simply returns a null descriptor. By overriding this method, processor implementations can support dynamic properties, since this allowed them to register properties on demand. It's acceptable for a dynamically generated property to indicate it is required, so long as it is understood it is only required once set. Dynamic properties by definition cannot be required until used. This is in the class abstract configurable component, which is in the package org.apache.nifi.components. If a processor will route a single flow file to potentially many relationships, this processor will be slightly different than previously described processor for routing data based on content. This processor typically use relationships that are dynamically defined by the user as well as an unmatched relationship. In order for the user to be able to define additional properties, the get supported dynamic properties descriptor method must be overridden. This method returns a property descriptor with the supplied name and an applicable validator to ensure that the user specified matching criteria is valid. Now we are considering route streams based on content one-to-many common processor patterns. This processor will override custom validate method. The method protected collection validation result custom validate validation context allows subclass to perform their own validation on the already set properties. Since each property is validated as it is set, this allows validation of groups of properties together. Default return is an empty set. This method will be called only when it has been determined that all property values are valid according to their corresponding property descriptors validators. This is in the class abstract configurable component, which is in the package org.apache.nifi.components. The previous description of root based on content one to many provides an abstraction for creating very powerful processor. However, it assumes that each flow file will be routed in its entirety to 0 or more relationships. What if the incoming data format is a stream and of many different pieces of information, and we want to send different pieces of this stream to a different relationships? For example, imagine that we want to have a root CSV processor such that it is configured with multiple regular expressions. If a line in the CSV file matches a regular expression, that line should be included in the outbound flow file to the associated relationship. If a regular expression is associated with the relationship has apples, and that regular expression matches thousands of lines in the flow file, there should be one unbound flow file for the has apples relationship that has 1000 lines in it. If a different regular expression is associated with the relationship has oranges, and that regular expression matches 50 lines in the flow file, there should be one outbound flow file for the has oranges relationship that has 50 lines in it. That is, one flow file comes in and two flow files comes out. Two flow files may contain some of the same lines of text from original flow file, or they may be entirely different. This is the type of processor that we will discuss in here. This processor name starts with root and ends with the name of data types that it roots. In our example here, we are routing a CSV data. So the processor is named root CSV. This processor supports dynamic properties. Each user-defined property has a name that maps to the name of a relationship. The value of the property is in the format necessary for match criteria. In our example, the value of the property must be a valid regular expression. This processor maintains an internal concurrent map where the key is relationship and the value is a type of dependent on the format match criteria. In our example, we would maintain a concurrent map relationship pattern. This processor overrides the onProperty modified method if the new property is applied to this method. The third argument is null. The relationship whose name is defined by the property name first argument is removed from the concurrent map. Otherwise, the new value is processed in our example by calling pattern.compile new value, and this value is added to the concurrent map with the key again being the relationship whose name is specified by the property name. This processor will override custom validate method. In this method, it will retrieve all properties from the validation context, and the count the number of property descriptors that are dynamic by calling is dynamic on the property descriptor. If the number of dynamic property descriptors is 0, this indicates that the user has not added any relationships. So the processor returns a validation result indicating that the processor is not valid because it has no relationships added. Now we are considering a root based on attributes in common processor patterns. This processor is typically very fast, so the at support batching annotation can be very important in this case. Annotation type support batching. Mark annotation, a processor implementation can use to indicate that users should be able to supply a batch during for the batch duration for the processor. If a processor uses this annotation, it is allowing the framework to batch process sessions commits, as well as allowing the framework to return the same process session multiple times from the subsequent calls to the process session factory dot create session. When this annotation is used, it is important to note that calls to process session dot commit may not provide a guarantee that the data has been safely stored in NiFi's content repository or flow file repository. Therefore, it is not appropriate, for instance, to use this annotation if the processor will call process session.commit to ensure data is persisted before deleting the data from the remote source. When the default duration parameter is set, the processor is created with the supplied duration time, which can be adjusted afterwards. The supplied value can be selected from default run duration. This is in the package org.apache.nifi.annotation.behavior. This This processor is almost identical to the root data based on content processor described previously. It takes two different forms, one-to-one and one-to-many, as do the content-based routing processors. This processor, however, does not make any call to process sessions read method, as it does not read flow file content. This processor is typically very fast, so the at support batching annotation can be very important in this case. Now we are considering split content one-to-many in common processor patterns. If a point is reached at which a flow file needs to be split, a new flow file is created via the process sessions create flow file method or the clone flow file long method. The method flow file create flow file content creates a new flow file in the repository with no content but with the parent linkage to parent. The newly created flow file will inherit all the parent attributes except for the UUID. This method will automatically generate a provenance fork event or a provenance joint event depending on whether or not other flow files are generated from the same parent before the process session is committed. This is in the interface process session, and which is in the package org.apache.nifi.processor. This processor generally require no user configuration, with the exception that of the size of each split to create. The onTrigger method obtains the flow file from its input queues. A list of type flow file is created. The original flow file is read via the process session's read method, and the input stream callback is used. Within the input stream callback, the content is read until a point is reached at which the flow file should be split. If no split is needed, the callback returns and the original flow file is routed to success. In this case, provenance route event is emitted. Typically, route events are not emitted when routing a flow file to success because this generates a very verbose lineage that becomes difficult to navigate. However, in this case, the event is useful because we would otherwise expect a forked event, and absence of any events is likely to cause confusion. The fact that the flow file was not split but was instead transferred to success is logged and method returns. If a point is reached at which the flow file needs to be split, a new flow file is created via the process session's create flow file method or the clone flow file long method. With create method, if using create method, the method is called when the original flow file as the argument, so that the newly created flow file will inherit the attribute of the original flow file, and provenance fork event will be created by the framework. The code then ensures try finally block. Within the final block, the newly created flow file is added to the list of flow files that have been created. This is done with the final block so that if an exception is thrown, the newly created flow file will be appropriately cleaned up. Within the try block, The callback initiates a new callback by calling process sessions writes method with an output stream callback. The appropriate data is then copied from the input stream of the original file to the output stream for the new file. You can use the clone method, the other method. If the content is newly created flow file is to be only the continuous subset of the bytes of the original file, it is preferred to use the clone flow file long method instead of the create flow file method of the process session. Now we are considering update attributes based on content in common processor patterns. This processor emits the provenance event type attributes underscore modified enum constant public static final provenance event type attributes underscore modified. Attributes underscore modified is used to indicate that the flow file attributes were modified in the some way. This event is not needed when another event is reported at the same time, as the other event will already contain all flow file attributes. This processor is very similar to the route based on content processors discussed before. Rather than routing a flow file to matched or unmatched, the flow file is generally routed to success or failure, and attributes are added to the flow file as appropriate. Attributes to be added are configured in a manner similar to that the route based on content one-to-many, with the user defining their own properties. The name of the property indicates the name of the attributes to add. The value of the property indicates some matching criteria to be applied to the data. If the matching criteria matches the data, an attribute is added with the name the same as that of the property. The value of the attribute is the criteria from which content that matched. For example, a processor that evaluate XPath expressions may allow user-defined XPath to be entered. If the XPath matches the content of the flow file, that flow file will have the attributes added with the name being equal to that of the property name and a value equal to the contextual content of the XML element or attribute that match the XPath. The failure relationship would then be used if the incoming flow file was not valid XML in this example. The success relationship would be used regardless of whether or not matches were found. This can be used to route the flow file when appropriate. This process emit provenance event type attributes underscore modified. Now we are considering enrich or modify content in common processor patterns. For the majority of cases, the processor is marked with at side effect free and at supports batching annotations. The annotation type side effect free mark annotation for a processor implementation can use to indicate that its operation on the flow files can be safely repeated across processor sessions. If a processor has this annotation and it allows the framework to manage session commit and rollback, then the framework may elect to cascade process session given to this processor's on-trigger method to the on-trigger method of the another processor. It can do this knowing that if the something fails along a series of processors using the same session, that can all be safely rolled back without any ill effect on external services which could not be rolled back, and thus all the processes could be safely repeated, implemented independent behavior. This is in the package apache.nifi annotation.behavior. The enrich modify content pattern is very common and very generic. This pattern is responsible for general content modification. For the majority of cases, this processor is marked with the at side effect free and at supports batching annotations. The processor has any number of required or optional properties depending on the process function. The processor generally has a success and a failure relationships. The failure relationship is generally used when the input file is not in the expected format. Now we are, as an exception example 2, we can consider process exception within the processor. From the framework perspective, there are two types of exception that can escape the processor: process exception and all others. The class process exception indicates an issue occurred in the user code while processing a flow file. This is in the package org.apache.nifi.processor.exception. During the execution of an on-trigger method of a processor, many things can potentially go awry. Common failure conditions include incoming data is not in the expected format, network connections to external services fail, reading or writing data to the disk fails, there's a bug in the processor or dependent library. Any of these conditions can result in an exception being thrown from the processor. From the framework perspective, there are two types of exception that can escape a process exception and all others. If a process exception is thrown from the processor, the framework will assume that this is a failure that is known outcome. Moreover, it is condition where attempting to process the data again later may be successful. As a result, the framework will roll back the session that was being processed and penalize the flow file that were being processed. If any other exception escape the processor, through the framework will assume that it's a failure that has not taken into account by the developer. Now we are considering processor behavior annotations. General design consideration, the event driven instruct the framework that the processor can be scheduled during the event driven scheduling strategy. This strategy is still experimental at this point, but can result in reduced resource utilization on data flows that do not handle extremely high data rates. The annotation type event driven annotation that may be placed in the processor that indicates to the framework that the processor is eligible to be scheduled to run based on the occurrence of an event. For example, when a flow file is enqueued in an incoming connection rather than being triggered periodically. This is in the package org.apache.nifi.annotation.behavior. Now we are considering run the processor in testing. After configuring the control services and enqueuing the necessary flow files, the processor can be triggered to run by calling run method in test runner. The method void run perform exactly the same operation as calling run init with the value of 1. This is in the interface test runner, which is in the package org.apache.nifi.util. After configuring the control services and enqueuing the necessary flow files, the processor can be triggered to run by calling run method of the test runner. If this method is called without any arguments, it will invoke any method in the processor with an onScheduled annotation. Call the processor's onTrigger method once and then run the @onScheduled and finally @onStopped method. If it is desirable to run several iterations on the onTrigger method before the other @onScheduled and @onStop lifecycle events are triggered, the run init methods can be used to specify how many iterations of onTrigger should be called. There are times when we want to trigger the processor to run but not trigger the @onScheduled on unscheduled and unstopped lifecycle events. This is useful, for instance, to inspect the processor's state before these events occur. This can be achieved using run int boolean and passing false as the second argument. After using this, though, calling the @onSchedule lifecycle method could cause an issue. As a result, we can now run onTrigger again without causing these events to occur by using the run init boolean version of the run method and passing false as the third argument. If it is useful to test behavior that occurred with multiple threads, this can be achieved by calling the set thread count method of test runner. The default is one thread. If using multiple threads, it is important to remember that the run method of test runner specified how many times the process should be triggered, if not the number of times that the process should be triggered per thread. So if the thread count is set to 2 but run 1 is called, only a single thread will be used. As an example, you can see here this. We can consider this one. Error failed to put a standard flow file recording here. Another information here. Now we are considering extension N. There are various types of NiFi extensions which are described in other documents. The key point here is that extensions operate and execute within JVM. NiFi is at its core built for extension, and as such it is a platform on which data flow processors can execute and interact in a predictable and repeatable manner. Points of execution include processors, controller services, reporting tasks, prioritizers, and customer user. As an example, we can consider this: create your UI, build and bundle VAR in your processor NAR. Step 2, the VAR need to contain a NiFi processor configuration file in the meta-inf directory, which associate the custom UI with that processor. Place the NAR in the lib directory and it will be discovered when NiFi starts up. Step 4, in the configuration processor window for the processor, the properties tab should now have an advanced button which will access the custom UI. To add a custom UI to a processor, the content of the ni-processor-configuration as follows: Apache org.apache.nifi.processors.attributes.update attributes $$ and then project.group id nifi-update-attribute-nar and again you have to give a project.version information. Custom UIs can also be implemented for controller services. And as an example, see example 2, we can consider this one, the use of org.apache.nifi.ui.extension.ui extension in project NiFi by Apache. Here you can see the method populate remaining controller service content in the class controller service resource. Here this will populate the URIs for the specified controller service. The code, the steps are here. As an example 3, we can consider this one, this property in NiFi-registry.properties file. This NiFi.registry.extension.dir1, the full path on the file system to the location of the jars for the given. As an example for, we can consider enum extension type. This is in the package org.apache.nifi.documentation. Now we are considering available configuration options in processor locations. The unique property identifier must appear in the property for each unique path. For example, here the NiFi na.library.directory.custom allows the admin to provide multiple arbitrary paths for NiFi to locate custom processes. A unique property identifier must append the property for each unique path. For example, here the NiFi.na.library.autoload.directory is used by the autoload feature, where NiFi can automatically load new processors added to the configured path without requiring a restart. For example, here. Now we are considering installing custom processors. Firstly, we will configure the directory for the custom processors. Here we describe the original processes for installing custom process that requires a restart to NiFi. Firstly, we will configure a directory for the custom processors. Ensure that this directory exists and has appropriate permission for the NiFi user and the group. Now we must place our custom processor now in the configured directory. The configured directory is related to the NiFi home directory. For example, let us say our NiFi home dir is /var./lib./NiFi. We would place our custom processor now in the y/var/lib/my-custom-nas/lib. Ensure that the file has appropriate permission for the NiFi user and group. Restart NiFi and the custom processor should now be available when adding a new processor to your flow. Now we are considering autoloading custom processors. For example, here we are considering the process to use the autoloading feature for custom processors. To use the autoloading feature, wi-fi.na.library.autoload.directory property must be configured to the point at the desired directory. By default, this points at ./extensions. For example, here, ensure this directory exists and has appropriate permission for the NiFi user and the group. Now we must place our custom processor now in the configured directory. The configured directory is related to the NiFi home directory. For example, let us say that our NiFi home directory is /var/lib/NiFi. We would place our custom processor now in /var/lib/NiFi/extensions. Ensure that the file has appropriate permissions for the NiFi user and the group. Refresh the browser page and the custom processor should now be available when adding a new processor to your flow. Now we are considering HDFS external resource provider in NA providers. This is the example configuration. This implementation is capable of downloading files from an HDFS file system. The value of the NiFi.na.library.provider's name, provider name here, implementation must be org.apache.nifi.flow.resource.hadoop.hdfs external resource provider. For backward compatibility issues, org.apache.nifi.hadoop.hdfs now provide is still an accepted implementation, but it is suggested to use org.apache.nifi.flow.resource.hadoop.hdfs external resource provider. Instead, features introduced with external resource provider might not work with this implementation. Now we are considering commands in NiFi CLI. You can see the command and args here. Registry list dash extensions. This is the full command format. Now we are considering custom processor UIs in UI extensions. To add a custom UI to a processor, step 1, create your own UI. Create your UI. Step 2, build and bundle your VAR in a processor NAR. Step 3, the VAR needs to contain an NiFi processor configuration file in the meta-inf directory which associates the custom UI with that processor. Step 4, place the NAR in the lib directory and it will be discovered when NiFi starts up. Step 5, in the configure processor window for the processor, properties tab should show now an advanced button which will access the custom UI. As an example here in the NAR layout for update attributes, with the contents of NiFi processor configuration as follows. Custom UIs can also be implemented for controller services and reporting tasks. Now we are considering content viewers. To add the content viewer, build and bundle your VAR in processor NAR. And step 2, the VAR needs to contain a NiFi-content-viewer file in the meta-inf directory. In which directory which lists the supported content types, and place the NAR in the lib directory and will be discovered when NiFi startup. And step 4, when a matching content type is encountered, the content viewer will generate the appropriate view. A good example to follow is the NAR layout for the standard content viewer. With the content of NiFi-content-viewer as follows. As an error example, we can consider this one occurred in building custom NiFi processor with controller service. Error could not generate extensions documentation. org.apache.maven.plugin.mojo execution exception failed to create extension documentation at org.apache.nifi.namojo.generate documentation at org.apache.nifi.namojo.execute. Now this is the end of my presentation. Thank you very much for watching it.